All right, welcome to the Explainer. Today, we are going to unlock a technique that will completely transform your slow, clunky code into something super fast and elegant. Look, if you've ever written a loop inside another loop and just watched your program grind to a halt, then you are about to meet your new favorite tool, for real. So what is this magic tool? Well, at its heart, it's really all about replacing a slow, brute force search with something way, way more efficient. And, the best way to really get it is to forget about code for just a second. Let's start with a simple puzzle.
Okay, picture this. You've got a long row of toy cars, and they're all sorted by a number on their roof. Your job? Find 2 cars that add up to exactly 10. Now, you could check every single car against every other car, but man, that would be painfully slow. So the real question is, if you had a friend helping you out, what's the absolute fastest way you could find that pair? Think about it.
The smartest way? Teamwork. It's so simple. You start at the very beginning with the smallest number, and your friend? They go all the way to the end, to the largest number. Then you just add your 2 numbers together. So what happens? Is the sum too low? No problem. You just move forward to a bigger number. Is the sum too high? Easy. Your friend moves backward to a smaller one. See? You both just keep moving inward, closing that gap until, boom, you land right on the perfect pair.
And right there, that's it. In that simple, almost obvious solution is the core idea. This whole thing of working from opposite ends and meeting in the middle, it's not just a clever little trick. It is a genuinely powerful computer science technique that solves problems with just incredible efficiency. Okay, so let's give this powerful idea its proper name. What we're talking about here is called the two-pointer pattern. So yeah, here is the formal definition. But really, what is it? Instead of having one lonely little pointer doing all the heavy lifting, we use 2 of them. You can literally think of them as our 2 friends from the toy car puzzle. They just scan through the data, moving in this really coordinated way to zero in on the solution much, much faster. And this is the payoff. This is why it matters. The slow way, the brute force way, we call that O of n squared. So with 10 items, that's 100 checks. Fine. But with 1,000 items, that's 1,000,000 checks. 1,000,000. The two-pointer method, though, that's O of n, just one single pass. So for 1,000 items, you do about 1,000 checks. That difference? It's not just big, it's gigantic. It's the difference between an instant solution and a program that you start, go make a sandwich, and it's still running when you get back. Okay, enough theory. Let's put this into practice with a classic coding problem. We're going to find a pair of numbers in a sorted list that adds up to a specific target. So here's the setup. We have a sorted array of numbers and a target value. Our mission, should we choose to accept it, is to find the locations, the indices, of 2 numbers in this array that add up perfectly to that target. All right, here we go. Here's our array, and our target is 7. So step 1, we put our left pointer at the very beginning, on -5. And the right pointer goes to the very end, on 6. Now let's check the sum. -5 plus 6 equals 1. Okay, 1 is way less than our target of 7. So what's the logical move? To get a bigger sum, we have to get a bigger number, right? So we move the left pointer to the right. Okay, so our left pointer is now on -2. Let's do the math again. -2 plus 6 is 4. We're getting closer, but 4 is still too low. The logic holds, right? To increase the sum, our only choice is to move that left pointer one more spot to the right. And now the left pointer lands on 3. So the sum is 3 plus 6. That's 9. Whoops. Now we've overshot it. 9 is bigger than 7. So this time, moving the left pointer isn't going to help us. That would just make the sum even bigger. To make our sum smaller, our only logical move is to take the right pointer and bring it inward, towards a smaller number. And just like that, we have it. The left pointer is on 3, the right pointer is now on 4. Add them up. 3 plus 4 is 7. Bingo! A perfect match. We found our pair. Do you see how we did that? We intelligently closed in on the answer, instead of just blindly checking every single combination. That is the power of this approach. But this technique is super versatile. It is not just for summing up numbers.
let's take a quick look at a few other superpowers these pointers have. So, how about this classic problem? Checking if a sentence is a palindrome. Reads the same forwards and backwards. Especially when it's a messy one, full of punctuation and capital letters.
You can use the exact same logic here. Pointer at the start, pointer at the end. There's just one little new rule. If a pointer lands on junk, like a space or a comma or a colon, it just skips over it to the next real character. Once both pointers are on actual letters, you compare them. If they match, great. Move both pointers inward and just go again.
Or what about this famous one? You get a list of numbers that represent the heights of different vertical lines. The question is, which two lines can you pick to form a container that holds the most water?
You probably guessed it, pointers at both ends. Now, the key here is that the amount of water you can hold is always limited by the shorter of the two lines. And here's the beautiful, elegant insight. To even have a chance at finding a bigger container, you have to move the pointer that's on the shorter line. I mean, think about it, right? If you move the pointer from the taller line, your container gets narrower, and your height can't possibly get any bigger. So your only hope for finding a taller wall is to get rid of the short one you're currently using.
All right, so now that you've seen it in action a few times, how do you know when to pull this specific technique out of your developer toolbox?
Well, here's your mental checklist. First, are you working with something linear, like an array or a string? Check. Does the problem involve finding pairs, or maybe comparing things from opposite ends? Check. Is the data sorted, or does it have some kind of symmetric property? That's a huge clue. But honestly, the biggest signal of all, it's when you look at a problem and you see that slow O of n squared loop inside a loop solution, and you just know there has to be a faster way.
Look, if you forget all the formal terms, the O of N stuff, just remember the toy cars. The two-pointer technique is it's like two friends searching from both ends of a line, meeting in the middle and finding the answer together. It's simple, it's about teamwork, and it's pretty much always faster than going it alone.
And there you have it, the two-pointer technique. It's elegant, it's incredibly efficient, and now it's part of your personal toolkit. So the only real question left is, what problems are you going to solve with it? Thanks for joining The Explainer.